Hello, ladies and gentlemen. My name is Jason Kabi from Center for Data Science and Artificial Intelligence, Dedan Kimathi University of Technology in Kenya. Welcome to my presentation today. My co-author on this paper is Dr. Shira Maina, who is the director at DCEL, and also a key figure in the Data Science Africa organization, that is DSA. So my presentation today will be on leveraging IoT and machine learning for improved monitoring of water resources. It's a case study I'm doing for the upper Ewaso Nyiro River located in Kenya. When I say monitoring, I mean monitoring the water level, the water turbidity, and the water flow rate in the river channel. So moving on to my first slide. Now a little bit of geography here. So River Ewaso Nyiro is located in the Ewaso Nyiro Basin, located in central Kenya, and it also extends to the eastern part of Kenya. So the river snakes its way through the basin, as you can see on the image, on your left. So the yellow patch there, that is the Opajeta Conservancy in the river basin. That's where we deployed our systems. And the river is also depended on by farmers in the fertile regions of the basin, and also pastoralists and other people in the arid and semi-arid areas of the basin. So generally is a very important part of the ecosystems in the Ewaso Nyiro basin, because it's also depended on by wildlife in some of the conservancies in the basin. So moving on, the motivation behind the research is equitable distribution and sustainable use of water. So you need data to quantify such kind of phenomena, equitable distribution. So you need data for that. Also sustainable use of water, to quantify that you need data too. So that is one of our aim. Also quantifying phenomena like catchment degradation. When I talk about catchment degradation, I mean when due to catchment degradation is caused by human activities or human encroachment into the catchment. So when there is runoff due to the land being bare, the water level in the river increases rapidly, and so with sensor nodes deployed along the river, you can note that increase as soon as it happens. So using that, you can able to determine the rate at which the catchment is degraded, or the degree of degradation. So using that data collected. So also nowadays there is high demand for data for environmental modeling. So this is data for water level data. You can use to build prediction models for the river, maybe to study past trends, and also to study future trends of the water level in the river, considering other factors. So our research objectives, the first one was to design the system, of course, to collect the data, the water level data in the river channel. Also to deploy a network, that is the LoRa network, IoT network, to handle the data transmitted between the sensor nodes deployed, fixed nodes deployed along the river, data transmission to the network server. So the network server, it is the sensor nodes network server, in this case the TTN, the links network, the database, and from there web infrastructure to handle the visualization, machine learning to handle anomaly detection in the data set, and also we can make conclusions from the data. So like I said, on the methodology, we have water level data collection using the nodes, then the LoRa communication, then the LoRa gateway that enables communication between the nodes and the network server here, the links network, that is TTN, the links network. From there, the database on Google Cloud, then from there machine learning prediction models, then anomaly detection, then we manage to display the data on a dashboard, on a web app also. So the LoRa One network. So we carried an installation test to determine the operation radius. So as you can see, when the sensor node is close to the gateway, or near the gateway rather, the received signal from the node is high. As we move far away from the gateway, the received signal is low, and we managed to get a radius of around 8 kilometers, a radius of operation, and a huge section of the river runs through that 8-kilometer section, so it gave us a wide enough area to deploy our systems. So this was basically that, to test the range of communication. On my 6th slide here, you can see that the reason why we chose LoRa, the long range wide area network, is because of power consumption, that is low power consumption, and a wide area of communication. So those were the two main factors that we considered. So moving on, you can see we deployed our gateway around 18 kilometers above ground, and we were able to get that 8-kilometer operation radius, and that was good enough. So this shows our first prototype. You can see there you have the microcontrollers, the power regulators, the batteries, the solar panel to handle the charging. But we decided to put the prototype in a cage to give it extra protection. Remember, we are deploying it in a conservancy. There are primates, birds. So to give it that extra protection, we decided to put it in a cage and deploy it. Now on the left there, you can see, on the right, sorry, you can see the sensor location at the bottom of the cage. So these are the actual deployed systems. They are still running. We deployed them in May, that is 2020. They are still running to now, and we are still collecting data from them. So anomaly detection. So I talked about anomaly detection as a method of detecting anomalies in various data sets. Our data set is a time series data set because the varying factor is time. So we were able to utilize a couple of unsupervised classification methods for this. The first one we considered was the k-means. We also considered the random forest, the LOF, that is the local outlier factor. Also, we did some interquartile range analysis to detect anomalies in our data. Now, the image shows the month of July 2020 clustered using k-means. So the cluster 1 shows that those are the correct data points. Cluster 3, cluster 4, and cluster 2 shows the incorrect data points, and using a few lines of code you can scrap them off, and you just remain with the cluster 1, and now you calculate a monthly mean for the data. Now comparison of the data with rainfall data. Now the blue bars there, you can see that is rainfall from May 2020 to January 2021. So the rainfall from TAMO is Trans-African Hydrometeorological Observatory. This is an organization that runs some weather stations in the Ewaso Nyiro basin and also around the world. So they are kind enough to provide us with the data, and we are able to draw the comparisons between our water level data and their rainfall data. As you can see, there is some striking similarity, if I may say, in that when the rainfall is high, the water level is high. As the rainfall reduces, the water level reduces, as you may expect. So on the right there, you have the catchment test. Catchment test, I talk about it in the next slide. So the catchment test, what we are trying to do as we started was to draw the comparison between when a spike in water level occurs, how long does a spike in water level occur after a spike in rainfall. So the duration between a spike in rainfall and the spike in water level. If the duration is long, maybe I say 4 days or 3 days or a week, it means that the catchment is possibly doing fine. But when the duration is short, it means the catchment might be possibly degraded to a certain degree. So that is one of the tests we are still running. So to conclude my presentation, So we managed now to deploy the sensor systems. We collected the data. We did anomaly detection on the data. We are still running the catchment test to determine whether the catchment is highly degraded or is doing fine. Also, we are displaying the data on a web app. That is the link to that web app, so that you can see the data coming in from the sensor nodes. So in future, we aim now to develop prediction models to predict the water level in the river. Also develop inundation models. Now, inundation models are used to, if I may say, predict floods, or come up with safe maps where the flooding can happen, where the flooding cannot happen, in case the river is inundated with water, or by water rather. So those are inundation models, and water level data happens to be one of the key inputs into an inundation model. So we aim to develop them. Also integrate our data set with other data sets. So like I shown you in one of my slides, that we are able to draw comparison between the rainfall data set from Thermo and our data set. So, but we aim to integrate other relevant data sets into the project. Also expansion to other rivers, and also expansion on the Ewaso Nyiro River channel. Also implementation of other methods of anomaly detection. I think I went through a couple of them in one of the slides. So we aim to implement other methods of anomaly detection, and maybe compare the results with the methods that we have already implemented. Also development of the water turbidity sensor systems and the water flow rate sensor systems. I mean, when I was starting the presentation, I took you through the whole course, in that we aim to develop the water level system, the water turbidity, the water flow rate. We have already developed the water level system, so we move on to the water turbidity and the water flow rate system. So that marks the end of my presentation. So I would like to thank the National Research Fund, that is in Kenya, for funding the project. Also the Data Science Africa for their support. Also Dedan Kimathi for the support, ARM for the support, Dedan Kimathi, the All Pajeta Conservancy for giving us the access we needed to the conservancy, so that we can deploy our systems along the river Ewaso Nyiro. Also Thermo, because they were kind enough to provide us with the rainfall data set so that you can draw comparisons and you can have a backup data set to back up our data. So as I conclude here, this is my contact information. Like I said, Jason Kafi, IDK.ac.ke. So my website is also on there. The DCEL, that is Center for Data Science and Artificial Intelligence website, is on there. All the material concerning the project is on it if you need to go through it. So at this point, I would like to invite any questions, and I would like to say thank you for your time. Have a nice day.